Howdy, everybody. We're going to cover two different sections in your notes that are in this lesson. So the first one is going to be units of measurement. A unit of measurement is a physical quantity of definite size. So there are standards unit of measurement important for science because we need to be able to keep track of our data and it needs to be communicated in a perfect way. So a great example of this is when they programmed the Mars lander in feet, but they made their calculations in meters. Well, the Mars lander didn't work out so well, and this actually really happened in one of their guidance systems. So that was not a good thing. That was a long time ago. You can look it up though. So now the SI system is a system that's used to standardize this. That's the International System of Units, or the SI system. SI is French, that's why the letters are backwards. And so they made a conference where they decided that we were all going to standardize these actual units and make sure that we had them. So they only focused on 7 of them, okay? Here you'll see 5. You'll see 1, 2, 3, 4, 5. There are 2 other ones that we won't use this year. I'll cover those in a second. So that is length. Length is in meters. And the symbol is m. So length is measured in meters. Now you can have centimeters, but we'll get to that. That's going to be the prefixes down at the bottom. Now there's mass. The standard unit for mass is the kilogram. Okay. It is not the gram, it is the kilogram. So be careful with that kilogram. The standard unit of mass is a kilogram. They call that the big K. They used to have just 1 kilogram sitting in a room in France, and that is what they based off of one. They based all other kilograms off this one tiny cylinder. So now the unit of time is a second with an S. The unit of temperature is Kelvin. That may be different for you, and it has a capital K. The reason why we use Kelvin is because Kelvin is an absolute symbol. We do not use Celsius, and we do not use Fahrenheit. We never use Fahrenheit, but we will sometimes still use Celsius. But the fundamental unit is going to be Kelvin. Now, the amount of substance, referring to the actual number of substance, is going to be considered the mole, and we'll use that one a lot. Now, the other 2 are going to be the amp and the candela. Those 2 are for physics. Candela has to do with the brightness of something, and then the amp has to do with current. So every other unit can be derived from this fundamental unit. So let's take a look at the derived units down here at the bottom of the page. Okay, so the derived units is a unit or a combination of the fundamental units. The most common ones that we'll see are volume, density, and speed. Okay, so volume is a combination of them. So if you take length times width times height, which are all units in meters right here, if you combine them together by multiplying them together, you get meters cubed, all right? Or centimeters cubed, or decimeters cubed. Okay, those are common ones we'll see. For density, it is mass divided by volume. So then you get kilograms per milliliter, kilograms per liter. You get kilograms per meter cubed, or you can get lots of different variations, grams per milliliter, and so on. But those are all derived off of fundamental units, okay? So, and then the speed is most commonly used as meters per second, like when we're talking about velocity. That's more of a physics thing, but the derived units are important for later, so make sure you just kind of keep those stuck in the back of your head. Now, let's talk about these prefixes. What I must say is that you must memorize these, please. Okay. You must memorize what the prefixes are. Specifically, I'm going to tell you this, that you need to, let's get that out of there, go away. Kilo is K. It's got the symbol K, and I want you to understand that K is worth 10 to the third, okay? What I mean by that is there are 10 to the third grams in a kilogram. There are 10 to the third meters in a kilometer or a kilometer, okay? And so forth. So you are taking one of the fundamental units that's right here, and you are adding a K to it, and it's shortening those numbers. So let's try that one more time. Kilo is going to be really important. Make sure you know that one. Milli is important. Centi is super important. And make sure you for sure know those. So kilo is 10 to the third. Centi is 10 to the minus 2. And then milli is 10 to the minus 3. We'll get more into how to convert these units a little bit later. But for now, you need to make sure that these are memorized. There will be a quiz. The next part of the lesson is going to be on significant figures. So I want you to look at this page in your notes. That's going to be page 6 down at the bottom. It says significant figures right here. So a significant figure in a measurement will include all the digits that can be known accurately plus one that must be the last estimated digit. That's that estimated digit thing that we were talking about. Now, what we're actually talking about is when we look at these numbers, how can you tell if something is significant? So let's say if I was to say that there's 1 million right here, and then in contrast, what if I said there's 1,000,001? Okay, those numbers look different because 1 million, just like to me, that sounds like an estimation. If somebody says there's 1,000,000 words in a book, I'm guessing that they're probably estimating. Now, if they say there's 1,000,001, now that makes it sound more exact. Okay, so that one carries significance, but that all these other zeros also kind of carry some kind of significance as well. So that's the idea that we're going to look at when we take a look at this. Now, there are just rules that you have to determine when you look at sig figs, and you don't have to memorize each one, but they're good for reference as you practice them. And as we go through the course, you will just get good enough practice where they won't be memorized anymore. You'll just know them. So for rule number 1, every non-zero digit in a recorded measurement is significant. By the way, sometimes these are called significant figures, right? But I will call them sig figs, okay? Or they can also be called sig digs because they are called significant digits, okay? Now, digits, we're talking about the actual placement of the number. Not the value of the number really, but the placement of the number is kind of what we're looking at. So for rule number 1, every non-zero digit in a recorded measurement is significant. So that is digits 1 through 9 are always significant. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9. Every digit between 1 and 9 is significant. So it's just the zeros that are the question mark. All right. So moving on, that's what all the other rules take care of. For number 2, zeros appearing between non-zero digits are significant. So 1005 has a significant digit here and here. Okay. So since these zeros are in between, then those are significant as well. This one has 4 sig figs, SF. Okay, 4 sig figs. Now, for rule number 3, zeros appearing in front of all non-zero digits are not significant. So these are called leading zeros. Leading zeros. I will write over this. This is going to be 0.000015. Okay, so all of these leading zeros are not significant. Just the one and the 5 are. Okay, so since there is nothing to the left, there's no non-zero number to the left of those. All these zeros are insignificant. So number 4, zeros at the end of a number and to the right of a decimal point are significant. So for 16.00, the key here is that if there's a decimal present. So this is how I like to combine basically rules 4 and 5. So are you paying attention? It's not written on your notes. You must listen to my voice. If a decimal is present, right here, after the first non-zero number, everything is significant. Okay? If a decimal is present. Okay? So this one has 4 sig figs. Now for number 5, zeros at the end of a number and to the left of a decimal are not significant. So check this one out. We have 2500. There is no decimal. So again, the 2 and the 5 are automatically significant because they are not zeros. Now, there is no decimal present, so these are not significant. So there are two sig figs here. Okay, that is how that works. So now, if you were to place 2500 and a decimal point at the end, even with no zeros behind it, all of a sudden, kaboom, everything becomes significant. Okay, so it is all about the decimal place. Is the decimal place there or not? Okay, so we're going to look at number 6. Number 6 is easy because it is just talking about when a number is written in scientific notation, you determine the number of significant figures by looking at the number of significant figures in the coefficient. Therefore, 1.500 times 10 to the third, or 10 to the whatever, that's what scientific notation looks like. This is called the coefficient right here. Anything to the left of the coefficient is significant. So that would be 1, 2, 3, 4. So that one has 4 sig figs. Anything to the left of the x, of that x right there, is significant. So let's take a look at some practice. All you have to do is determine the number of sig figs here. I'm going to do a couple and then I want you to try a few. So question number 1 is 2 sig figs because the leading zeros are not significant. It's just the 4 and the 5. Question 2 has 4 sig figs because these are significant, and then there's a decimal present. So after the first non-zero number, all of them are significant after the first non-zero number. And then for number 3, that one's easy. There are 3 sig figs because there's no zeros here. There's just 3 digits. And then for number 4, there is not a zero present, so there is 1 sig fig. Go ahead and try the rest. That's 1. Oop. That's 1. That's a 4. That's a 3. That's a 5. And then this one, for the grand finale of them all, 145002, 0. A decimal is present right here. So this one's significant. That means everything else must be. So that's 1, 2, 3, 4, 5, 6. 6 significant figures. Okay, so Mr. Russell, why am I learning how to do this? Well, it really tells you where to round, okay? So just to review, if it's 5 or greater, then you round up, okay? If it's less than 5, then you round down. Okay, so 5 greater than or equal to 5, then you round up. Oh, that should be an up. If it's less than 5, then you round down. Okay, so now, so let me just do some examples and see if you can kind of figure out what I mean by this. What we're going to do is we're going to round the following measurements to the number of significant figures indicated in the parentheses. So, for example, for A, I want to round it to 3 sig figs. So I have 58.96. I write it a little bit bigger so you can see it and it contrasts with the page. So we're going to take the first 3 digits, okay? And now this one is our rounding digit right here. So that rounding digit is greater than a 5, so it rounds up, okay? So that's going to make this one round up to a 0, okay? So that one's going to be a 0. Well, that means that I actually have to bump this one up as well. So that one's a tricky one to start off right off the bat, but this one's going to be 59.0, okay? But that one has 3 sig figs in it. Let me clean this up here for you. Try to get all this junk out of the way and move that. Try to delete that. Thank you. And move that one up. All right. I'll try not to do that next time. So for this one, we want to round this one to 2 sig figs. So we have our first 2 right here, 0.00245. Sorry, so much for color coding. We want to round to the first 2 sig figs. And so this one, it rounds up. So that's going to be 0.0025. Okay. Now we want to round this one to 1 sig fig. So for 4.62 times 10 to the minus 4, we're going to take that first sig fig right there, and we are going to round up. Okay, the next one is a rounding digit, so we're going to call it 5 times 10 to the minus 4. You can't forget that coefficient because those still hold place value. Okay, and this one's going to round. Oh man, it's going to round to 4700, 4700. This one's going. Ooh, tricky one, Mr. Russell. 4009. We want to take the first 2 digits. Okay, now this one is our rounding digit. Okay, which means it's a 0. It's going to round down or stay a 0. Okay, which means this one also needs to be a 0. Oh, okay. But wait a second. 4,000 does not have 2 sig figs. So here's the trick. Here's something you can do. Instead of, oh man, I am all messed up. Instead of writing 4,000 right here, which has 1 sig fig, you can put a line over that 0, and all of a sudden that line is telling you that this 0 right here is significant. Okay, so now that has 2 sig figs. So that's what that line is for. That's the only representation that line means. And then this last one does not tell you which one to round to, but let's go ahead and round it to 3 sig figs. So let's call it 3.93 times 10 to the third. Okie dokie. Now, once that's done, now we'll have to start to apply some rules of simple arithmetic. Now, first of all, addition and subtraction is where you find you actually just type in the number in your calculator, and your calculator will often give you many more decimal places than you need to. Instead of asking Mr. Russell, where am I supposed to round or how many decimal places you want, you need to use the correct number of significant figures. You will not ask me where to round. You will have to decide where to round yourself. So for the rules of addition and subtraction, you will take these three right here, these three numbers, and you'll punch them into your calculator, and you should get 29.347. Okay, that's what your calculator should say. Now, you want to use for addition and subtraction, the answer can have no more decimal places than the measurement with the fewest. So you're basically going to use the least number of decimal places. Well, this one has 2, this one has 3, and this one has 2 decimal places. We're talking about decimal places, not sig figs. So this one had, so we want to use 2 decimal places right here. Oh, so that must mean that this is my rounding digit. So I round up right here. That rounds up to a 5. So this one turns into a 5. So therefore, we become 29.35. That is my answer, and my units would be centimeters. Okay, since simple addition will just carry the units, it will not multiply the units. Now, for multiplication and division, now we are going to use, instead of the least number of decimal places, we're going to use the least number of significant figures. Okay, so when you type in this number and this number in the calculator, it will give you 2.59022 and a couple other numbers, but those aren't necessary. What you now want to use is the least number of sig figs. So I'm going to pick up my pencil and I'm going to underline my first 3 sig figs, because in my problem I had 4 sig figs here and 3 sig figs here. The least number is 3. So I'm going to use 3 sig figs in my answer. And then I'm going to look at this last digit. This last digit is my rounding digit. It just tells me where to round. Since it's a 0, it rounds down to a 0 and basically falls away. So my answer will be 2.59 grams per milliliter. Okay. Since we're doing addition, subtraction, multiplication, division, the units will stay together, and you have to write the units this way. Okay, grams per milliliter. Alrighty then. So checking out this last one, go ahead and see if you can practice this. Practice your rounding, practice everything. I'll pause for you, and welcome back. So hopefully you should have gotten, for this one, you should have gotten 33 centimeters cubed, because you're multiplying those centimeters together. So all those centimeters have to compound. So they have to be centimeters times centimeters times centimeters, which is also known as centimeters cubed. Now, this next one, since you only had, since that one right there didn't have any decimals in it, your answer will have 8 grams. Okay? It feels like you're cutting off a lot of numbers, but you'll see later why we do this. And then the next one is going to be 0.321, and then the units are grams per milliliter. And then the next one is going to be 200.0 meters squared. And then the last one is going to be 0.21 grams. All right. Well, I hope you enjoyed that as much as I did. I love doing sig figs. I'll be a stickler for them at the beginning because that's when we're learning. But later on in the year, I'll relax a little bit on your sig figs. I just want you to make sure you understand what they are. All right. Have a great day.